Hello, and welcome to Module 8.2, Division Properties of Exponents, Power of a Quotient. Our objective for today is I can find powers of quotients. Now, the power rule, when it applies to a quotient, or times when we have division, you are going to raise both the numerator and the denominator to the power, and then you are going to simplify. So if we look at letter A, we've got 3/4 the quantity to the second power. So that is going to distribute to both the 3 and the 4. So you're going to have 3 to the second power over 4 to the second power. And then we're going to go ahead and simplify. 3 to the second power is 9. 4 to the second power is 16. And we're done. Letter B. We have 9/3 to the third power. So conventional wisdom says we apply the exponents and we do that. So we do 9 to the third and 3 to the third, which would give us 729 over 27, which when you divide is 27. Now, on problems like this, what I would suggest doing is first, we'll do our alternate world, I would first simplify inside the parentheses. So 3 divided by 3 is 3 to the third power, which is 27. All right. Letter C, we are going to distribute to our exponents, right? And each one of these, remember, have an exponent of 1. So we have 1 to the fourth power over 3 to the fourth power. 1 times 1 times 1 times 1 is 1. 3 times 3 times 3 times 3 is 81. So it's 1 over 81 is our answer. Letters E, F, and G are there for you to do on your own, and then you're going to check your work against mine. So we're going to do the same thing here. We distribute. We have 2 to the third power over 4 to the third power. 2 times 2 times 2 is 8. 4 times 4 times 4 is 64. And that is going to, both are divisible by 8. It's going to reduce to 1/8. So your alternate reality is if you simplify inside the parentheses, right, and then you distribute, you have 1 to the third power over 2 to the third power, which gives you 1 over 8. Either way, you're going to get to the same point. It's just a little easier sometimes to do that division first and work with smaller values and things that maybe you're more familiar with. All right, letter F. Distribute. We have 5 to the third power, 2 to the third power. So 5 times 5 times 5 is 125. 2 times 2 times 2 is 8. And our last one, letter G, we distribute and we apply the exponent. We have 2 to the fifth, 3 to the fifth. 2 to the fifth power is 32. 3 to the fifth power is 243. And since we already know, the original fraction is 2/3, there's nothing that we can simplify here. All right, so let's take a look at example 4, which is power of a quotient with variables. So when raising a quotient to a power, raise the numerator and denominator to the power and simplify. The rule is the same, and we're now just going to apply it with variables instead of numbers. So A and B, remember they both have exponents of 1 on them, so it's A to the fourth over B to the fourth. Now, letter B here, we have exponents already that we're applying to, right? So it's going to be, remember, when we have parentheses, we're going to multiply those exponents together. So we have x to the second times fourth over y to the third times fourth. And we get x to the eighth over y to the 12th. Letter C. we have a negative exponent on both of these. So we're going to go ahead and multiply. So we have x to the negative 1 times negative 4 over y to the negative 2 times negative 4. And we get x to the 4th over y to the 8th. All right. Now, at the bottom of the page here are 3 you try problems. I want you to do those and then check your work against mine. So letter E, we're going to distribute, right? Exponents of 1 on each of those. You have x to the 1 times 3. We have 4 to the 3rd. We've got x to the 3rd power over 4 times 4 times 4 is 64. Letter F. Again, we distribute. Both of those terms have a 1 for their exponents already. So we've got 5 to the 3rd power over y to the 3rd power. And that's going to be 125 over y cubed. Lastly, letter G, we have a 2 and an x. And we get 2 to the 5th power over x to the 5th power. 2 to the 5th is 32 over x to the 5th. We're going to move to our next page. And we have power of a quotient. Now we've got all kinds of things going on. Chaos is breaking loose on this, and we need to do a lot of work. So let's take it methodically, step by step. Remember, each of these is going to have an exponent of 1 on them when they don't have an exponent already identified. So we do our distribution. So we have 2 to the 6th power, x to the 6th power, y to the 18th power. And then to the denominator, this is all over z to the 12th power. None of our variables cancel. There's no coefficients to cancel. And so we are left with this as our final result, except we have 2 to the 6th power. We need to actually do that math. So 2 times 2 times 2 times 2 times 2 times 2 is going to give us 64 x to the 6th, y to the 18th, over z to the 12th. All right, letter B. There's 2 ways to approach this. And I'm going to work through both ways for you so that you can see the difference between them. The first way is going to be we're going to distribute and we're going to apply that 4 to everything. So we have 2 to the 4th power, x to the 10th, x to the 20th power, 4 times 5, 4 times 3, y to the 12th power, 4 times 2, 4 times 2, so we have z to the 8th power, all over 3 to the 4th power, x to the 8th power, y to the 4th power. So now we simplify coefficients. 2 to the 4th power is going to get me 16. 3 to the 4th power gets me 81. And then x's, where do I have more x's? I have more on top. It's going to be x to the 12th because 20 minus 8 is 12. Where do I have more y's? I have more y's on the top. 12 minus 4 is 8. And there's only z's on the top, so it's z to the 8th. So that's one way of doing it, okay? Your alternate way would be, instead of doing all this messy distribution, we're going to start by simplifying. We're going to simplify our fraction as much as we possibly can. So the 2/3, there's no simplification there. X to the 5th over x squared. Where do I have more x's? In the top. How many more do I have? I have 3 more. Y to the third over y. Where do I have more y's? In the top, and I have 2. Z squared over nothing. Z squared stays at the top. Okay, and we put the 4 on the outside. Now, if you do the division, you're doing the same thing, but it's already been simplified for you. So you're still going to get 16 x to the 12th, y to the 8th, z to the 8th over 81. The choice is yours, whether you choose to simplify beforehand and then distribute, or whether you choose to distribute first and then simplify. The choice is yours. You're still going to be doing the same amount of work either pathway you take. I will say I personally would rather simplify before I do any applications of the power rule. I would rather simplify first. All right. Letter C. So I'm going to work my way through the way that I prefer, which is to simplify my fraction as much as I can. So the -3, the coefficient doesn't change. Where do I have more x's? I have more in the bottom, and I have 7 more, and I have z to the 3 and third in the bottom, and that whole thing is being raised to the third power. So now I distribute to all of my pieces using the power rule. So I have -3 to the third power over x to the 21st, z to the 21st. And when I multiply that out, I get -27 over x to the 21st, z to the 21st. All right. So you're going to try letters E, F, and G on your own, and we're going to go over them. So I'm going to go by the simplification route first. Where do I have more x's, top or the bottom? I have more x's on top, and I have 3 more, because 4 minus 1 is 3. Where do I have more y's? Well, it's the same in both, so they cancel out. And we're left with z in the denominator, and the whole thing is being squared. So now when I do that, and I apply the power rule, we have x to the 6th over z squared. Right. Letter F. We have 5x squared over 6x cubed, all to the third power. Again, I'm going to simplify where I can. And so 5 over 6, nothing changes. My denominator, or my variables, x squared, x cubed, there are more x's on the bottom than there are in the top. And so I do the subtraction, and I get just an x, and that whole thing is being raised to the third power. So I apply power rule, and I'm going to get 5 to the third power over 6 to the third power, x to the third power. And when I actually do that application of the exponent, we get 125 over 216x cubed. Letter G, I want to simplify again. So 4 over 3, no simplification there. They are the same. M squared over m squared cancels out. N squared, there's only an n squared in the numerator, so it stays in the numerator. P squared over p, well, there's one more p in the numerator than there is in the denominator, so it just stays in the numerator, and it's p. And this is all to the 4th power. Sorry, yes, to the 4th power. All right, now we apply power rule, and we multiply it by the exponents of all 4 of our pieces. So we get 4 to the 4th power. We have n to the 8th power. We have p to the 4th power over 3 to the 4th power. And when we do that math, 4 to the 4th power is 256. N to the 8th, p to the 4th, over 3 to the 4th is 81. All right, we're going to take a look at our 2 problems at the bottom here that bring it all together, where we are using product rule, power rule, division rules. We're doing all of it in one big show. So let's look at it. Let's unpack it. Where do we start? First thing, like order of operations, I'm going to start with those parentheses, and I'm going to work on fixing that. So let's do that. We've got the 3 being applied to everything in the parentheses. So everything on the outside, we're going to remain the same. So we have 2xy squared. Okay, and then we've got a 2 to the 3rd power. We have an x to the 9th power. We have a y to the 3rd power, and we have a z to the 12th power. Okay. And down below, we had z times z squared. Well, let's just combine that right away as z to the 3rd power. So now we've got pieces all over the place. Start with our coefficients. We've got 2 to the 1st and a 2 to the 3rd. So that's going to be 2 to the 4th. All right, we're going to group our pieces together. So now I have x to the 1st, x to the 9th. So that's going to be x to the 10th power. Okay. Then I have y to the 2nd and y to the 3rd. So that's y to the 5th power. And then we have a z to the 12th power in the numerator. So that's just combining on top, and we've got z cubed in our denominator. So the last thing we need to do is simplify the denominator. So 10z cubed, so 12 minus 3 is 9. So 2 to the 4th is 16, x to the 10th, y to the 5th, z to the 9th. And that's your final answer for this problem, letter A. I want you guys to try letter B now. So you're going to have to apply quotient rule a couple times, and you have multiplication properties to work with here. So let's work on it on your own and then check your work against mine. All right, so let's dive in. On the first one, we have 4 being distributed and applied to all of those terms. But what I'm going to look at before I even do that, let's simplify. Because what I see here is I have y squared and y squared. I really don't want to do extra work that I don't have to do. So we have 4x over 1, and we have a 4 on the outside. All right, my second set of parentheses. I have a fraction that I can simplify, and I'm going to do that. So 2/8 is going to become 1/4. Okay? And then I have an x to the 3rd and an x. There are 2 more x's in the denominator than there are in the numerator. And we have y to the 4th in the numerator. And this is all being squared. Now that I have simplified, now I'm going to apply all of my exponents. So we apply power rule and we distribute that to everything. And you'll notice I kept it as 4x over 1. Just because we're going to keep that as a fraction because there is a fraction being multiplied by a fraction here, and it just helps us keep that in our visual mind. So we have 4 to the 4th power, x to the 4th power, okay, and it's over 1 to the 4th power, which doesn't matter, it's just 1. So then our second set of parentheses here, we have the 2 that's going to be applied to all of our pieces. So we have 1 to the 2nd power. We have y to the 8th power. We have 4 to the 2nd power. And we have x to the 8th power. All right. So, sorry, x to the 4th power. 2 times 2 is 4. So now let's go through and simplify. 1 to the 2nd cancels. I mean, 1 to any power is still just 1. So it cancels away. We just left it there as placeholders just to kind of keep in mind that those things were there. So now we do 4 to the 4th. 4 to the 4th power, and we have 4 to the 2nd power in the denominator. So that's going to be 4 to the 2nd power. 4 minus 2 is 2. Okay, so let's just keep in mind we've got a numerator, we've got a denominator here. Okay, so that cancels, that becomes a 2. So x to the fourth and x to the fourth cancel out, and we're left with a y to the eighth in the numerator, and the denominator, everything canceled out and is just 1. So now we can simplify. 4 squared is 16, y to the eighth. Now it's important to keep in mind when we cancel out, it doesn't become 0, it's 1, right? It's anything that divides by itself is 1. And so make sure you're keeping track of where those ones are. Are they in the numerator or in the denominator? You can't just magically make something move from one part to the other without a mathematical reason for it. All right, so that's the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.